Hello, welcome back to Learn Economia. In this video, we are going to discuss an important topic in the arena of econometrics. Many of you might be wondering why I'm doing so many videos on econometrics in a continuous manner. Actually, this particular video is based on a request. I never wanted to make the person unhappy by not considering his or her request. That's why I have taken this topic. After this topic, we will be doing videos on other aspects of economics as well. Okay, with that, we are starting today's session, that is co-integration. Before co-integration, you have to understand certain very basics of the topics of econometrics, especially the difference between time series data, cross-section data, etc. So when I say co-integration, this is with respect to time series data. That means that you have data on different years with you, and you are looking into the data. So co-integration is actually, this is a kind of test, okay, and this is used to analyze whether your data is stationary or not, whether your data have a variances and means that vary over time or not. So that is your primary motive, and that is what you are testing with it, by looking for co-integration in your data, okay. Or you can say that this particular method of co-integration will helping you it will help you to estimate the long run parameters or the equilibrium in the systems with unit root variables. We can say that two sets of variables are co-integrated if it satisfies certain conditions. That means that if the linear combination of these variables has got a lower order of integration, then you can say that there exists some co-integration. If you go for an example, you can say that just take the case of you having a set of I1 variables and a combinations of I0 variables. Okay, and co-integration exists if a set of I1 variables can be modeled with a linear combination that are I0. Okay, and it is very important to go for the order of co-integration or the order of integration. And this is something which tells you that if you're going for I1 integration, that means that that means that a single set of differences, it could transform the non-stationarity variables into stationarity. I mean, this is very important to understand whether you have to follow how many steps, whether you have to follow one step or two step or three step to transform your non-stationary data into stationary one. So here I1 means that you can just go for the first difference to transform the non-stationary data to make it stationary. Although looking at a graph, it is sometimes it is sometimes if it tells you that I1 process is enough, uh, still what you have to do is that you have to go for some co-integration test to ensure that your data is not non-stationary but it is stationary. The augmented Dickey-Fuller test is a very famous test which is used to understand the co-integration in your data. So that test can be used to see whether your data is stationary or not. If you look into the background of co-integration, we can see that especially with respect to time series analysis, we know that we have already discussed some videos on Gauss-Markov theorem, ordinary least square estimate, etc., etc. So an important assumption in the Gauss-Markov theorem is that the variances and means of the series are constant and are independent of time, which means that the stationarity assumption. Non-stationary time series means that you have unit root variables in it. That means that your data is not stationary. Okay, and these series have to be analyzed by using different methods, and one of the methods is co-integration. That is what we are going to discuss here. And we have to see whether you have to go for you have to see whether you should follow an iterative procedure of step that has to be done, whether it has to be done once or twice or thrice, or that actually depends. It depends upon the kind of the data you have. Now we are going to discuss the different types of tests for cointegration. Okay, we can see that mostly people use three different methods, that is Engle-Granger test, Philips-Ouliaris test, and Johansen test. We will be discussing each of these tests in detail. First of all, Engle-Granger test. Okay, Engle-Granger method, and this is something which is based on your error term, that is your residual term, and also it is based on static regression analysis. Here you will be testing your error term, or you will be testing your residuals for the presence of unit root, and for this you will be using different methods like ADF or similar kinds of methods. And if the time series or if the data is cointegrated, then the residuals would be practically stationary. This test has got many issues. One of the important issues is that uh, dependent variable may lead to different conclusions, and this issue is corrected by similar methods like Ouliaris, Ouliaris and Johansen's test. Here the null hypothesis is that there is no cointegration, and alternative hypothesis that there exists cointegration. Coming to the next test, that is the Philips-Ouliaris test, and this too is a residual based unit root test, which as we have already told, this is an improvement over the previous test that we have discussed, that is the Engle-Granger test. It has since it had certain limitations, and Philips Ouliaris test has it could make up and it could be considered as an improvement over this particular, it is considered as an improvement over this test. So this we have to see whether it is actually an improvement or not. Okay, here the assumptions that the regression errors are independent with common variance. Okay, and here the null hypothesis that there is no cointegration as in the case of the earlier test. Here also the alternative hypothesis that there exists cointegration. And this particular test takes a supplementary variability into consideration, and it is considered to be invariant to normalization of cointegration relationship. Coming to the final test, that is the Johansen test. This too is considered to be an improvement over the Engle-Granger test. It avoids the issue of choosing a dependent variable, and also this particular test, when you compare this test with the Engle-Granger test, you will be able to see that you will be you these in the case of this particular test, errors are carried from one step to the next. Here issues with respect to that could be to an extent avoided, and this test can detect multiple cointegrating vectors as well. So that's all for cointegration. I hope that the person who has asked for this video can use this video as a what, as a guidance. Like this, anybody can make your request. I'll be taking up the request. I'll be, just comment the session that you need. Just comment the video that you need or the topic that you need in the comment box, so that I'll be picking it up and I'll be making the video on the same. So that's all for today. Please like, share, and subscribe to this channel for more videos, and you can be a part of my Telegram group and Telegram channel. I'll be providing the links of both my Telegram group and Telegram channel in the description box. Many people are there, and many are discussing there. So I'm very much happy to say that many people are benefiting a lot out of making discussions in the group. So you can also be a part of my group. I'm very much happy to invite you to be a part of my group. So Just consider this as an invitation. You can be a part of my group. So that's all for today. Thank you.